Good day, esteemed researchers and curious minds tuning in from around the globe. Today, we delve into the fascinating world of large-scale text summarization with our study, From Local to Global, a graph-or-age approach to query-focused summarization. We tackle the challenge of summarizing vast volumes of text, pushing the boundaries of large language models. Our innovative graph-RAG approach promises a fresh perspective on global summarization, offering intriguing insights and potential solutions. Let's embark on this journey of discovery together. The challenge we're addressing here is the query-focused abstractive summarization over an entire corpus. Existing methods, such as retrieval-augmented generation and query-focused summarization, have shown limitations when dealing with large volumes of text. The problem is twofold. First, information can be lost in longer contexts, which exceed the context windows of large language models. Second, the direct retrieval of text chunks in naive RAG is inadequate for QFS tasks. Our solution to these challenges is the graph-RAG approach. This method allows for global summarization of a knowledge graph derived from a large language model. We utilize community detection to partition the graph index. This enables the large language model to summarize in parallel, providing a more efficient and comprehensive approach to query-focused summarization. Our approach employs a map-reduce strategy, where each community summary independently answers the query. These individual responses are then synthesized into a final global answer. This method ensures complete coverage of the underlying graph index and the input documents it represents. This comprehensive approach allows us to extract and summarize information effectively, providing a robust response to any given query. Our research addresses the challenge of query-focused abstractive summarization. This is a complex task that involves understanding and summarizing vast amounts of text data, often exceeding the limits of traditional language model context windows. We aim to improve upon existing methods, such as the retrieval-augmented generation, or RAG, by introducing a novel approach. Our motivation stems from the need to understand connections among people, places, and events, and to anticipate their trajectories. The figure you see here illustrates our graph-RAG pipeline. It uses a language model-derived graph index of source document text, detecting and extracting nodes, edges, and covariates. These elements are then summarized and partitioned into groups using community detection, allowing for parallel summarization. This process ultimately leads to the production of a global answer to a query. Existing approaches to answering user queries over entire datasets, such as retrieval-augmented generation or RAG, often struggle when dealing with large volumes of text. Information can be lost in longer contexts, and a simple RAG approach may not be adequate for tasks like query-focused summarization, or QFS. To address these limitations, we propose a new method, graph-RAG. This approach is based on the global summarization of a knowledge graph derived from a large language model, or LLM. It's designed to overcome the challenges posed by existing methods and provide a more effective solution. One of the key innovations in our proposed method is the use of a graph index that spans nodes, edges, and covariates. This index is created from the source document text and includes entities, relationships, and claims that have been detected and extracted. Another significant innovation is the use of community detection algorithms. These algorithms partition the graph index into groups of elements that can be summarized in parallel, both at indexing time and query time. This approach allows us to effectively manage and process large volumes of text, making it possible to answer global queries more efficiently and accurately. Our research introduces a novel approach to producing a global answer from large volumes of text. This is achieved through a final round of query-focused summarization over all relevant community summaries. This method allows us to effectively manage and summarize extensive text corpora, making it possible to answer complex queries in a comprehensive and efficient manner. This innovative approach opens up new possibilities for handling large-scale data and enhancing our understanding of broad issues and themes. Our research introduces a novel approach for query-focused abstractive summarization, which we call Graph RAG. This method utilizes a knowledge graph derived from a large language model, or LLM. This graph index includes various elements such as nodes, edges, and covariates. We employ community detection to partition this graph index, allowing for parallel summarization. Now, let's delve into the technical details of the Graph RAG method. We use a MapReduce approach for summarization. The community summaries are divided into chunks of a pre-specified token size. These intermediate community answers are then generated in parallel. The answers are sorted by a helpfulness score and added to the context window until the token limit is reached. This process ensures a comprehensive and efficient summarization of the entire corpus. Our research introduces a unique approach, the Graph RAG method. This method leverages a graph index and community detection in a novel way. It addresses the limitations of existing methods like retrieval-augmented generation and query-focused summarization. By partitioning the graph index into manageable chunks, we ensure no information is lost, overcoming the challenges of large volumes of text. In terms of experimental design and evaluation, we used a large language model to generate a diverse set of questions from real-world datasets. We evaluated our approach on 3 key metrics: comprehensiveness, diversity, and empowerment. The results were promising. Our method outperformed the traditional RAG approach on comprehensiveness and diversity. Moreover, it showed favorable performance over source text summarization and did so at lower token costs. This suggests that our Graph RAG method is not only effective, but also efficient. Our evaluation was conducted on 2 real-world datasets: podcast transcripts and news articles. We focused on 3 key aspects: comprehensiveness, diversity, and empowerment. The results were quite revealing. All global approaches, including ours, outperformed the traditional retrieval-augmented generation, or RAG, in terms of comprehensiveness and diversity. But what stood out was the performance of our Graph RAG approach when using intermediate and low-level community summaries. Not only did it show superior performance, but it also managed to summarize large volumes of text more efficiently, resulting in lower token costs. This means we can provide more comprehensive and diverse answers while using fewer resources. In essence, our Graph RAG approach offers a more efficient and effective way to summarize large volumes of text, making it a promising tool for understanding and navigating complex datasets. Our research introduces a novel approach, Graph AG, which addresses the challenge of query-focused abstractive summarization over an entire corpus. It effectively overcomes the limitations of large language model context windows. The figure displayed here compares Graph RAG with other methods across 2 datasets. The results clearly show that all Graph RAG conditions outperform the naive RAG approach in terms of comprehensiveness and diversity. Furthermore, conditions C1 to C3 also demonstrated slight improvements in answer comprehensiveness and diversity over global text summarization without a graph index. This underscores the potential of Graph RAG in enhancing the efficiency and effectiveness of information retrieval and summarization. Our Graph RAG methodology utilizes community detection to partition the graph index, enabling parallel summarization of large volumes of text. This is a significant step forward in handling the challenge of summarizing extensive text corpora. When it comes to generating answers, we employ a final round of query-focused summarization over community summaries. This is facilitated by a MapReduce approach, which ensures the generation of thorough and relevant answers to user queries. In terms of evaluation and results, we tested our approach on 2 real-world datasets. The results were promising, with our method outperforming existing techniques in terms of comprehensiveness and diversity of the answers generated. Looking ahead, there is potential for further refinement and adaptation of our methodology to different data types and questions. This indicates that there is still room for further development and application of our graph RAG approach. This is an exciting prospect, and we look forward to seeing how this methodology can be further optimized and applied in various contexts. Our research concludes that the graph RAG approach provides a superior data index for global queries. This is a valuable tool for researchers and analysts who are working with large volumes of text. It allows for comprehensive, diverse, and empowering answers to complex queries, making it a powerful asset in the field of information retrieval and understanding. However, it's important to consider the context in which the graph index is used. The investment in this approach depends on several factors, including your compute budget, the nature of expected queries, and the value you anticipate from the graph index. While it may not be suitable for all situations, in the right context, it can be a game changer, enhancing the efficiency and quality of data extraction and summarization. In essence, our work presents a novel approach to global summarization, balancing the needs of efficiency and quality, and paving the way for more effective sense-making in large text corpora.